Hi everyone. So our next topic is adaptive Huffman coding and coding procedure. In our previous video, we have discussed about the adaptive Huffman coding update procedure. Now in this video, we will discuss about how to encode the given string as per the adaptive Huffman coding. And in next video, we will discuss about the decoding procedure. As I have already tell you that the adaptive Huffman coding uh, having three steps. The first one is update procedure, then second one is encoding, and the third part is decoding part. Okay, so in this video we will discuss about the encoding part, means encoding procedure. So these are the contents. We will discuss about the rules which we'll use in encoding part and what will be the conditions. On the basis of condition, we will follow the adaptive encoding part. Okay. Now then we will discuss we will discuss an example in which we just encode our sequence. Okay. So now come to the rule part. So there are certain rules which we have to follow for encoding the adaptive encode. Okay. So for first rule is if the symbol is encountered first time, okay, then the NYT code followed by the first code. Okay, suppose we have a sequence like A R D B A R N. Okay, if the symbol is encountered first time, then the code will be NYT code followed by first code. Okay, it means that for a particular symbol we have to find the two codes. First is NYT code and the second code we have to find out is fixed code. Okay, so we have to, for a particular symbol we have to find two code. First is NYT code and the second one is fixed code. Okay, now the second rule is symbol is already encountered, only send code from the symbol. Now as per the rule second, if the symbol is encountered second time or third time, means you already encountered, then in that case we just only send the code for a symbol. Means suppose we have a tree like this. Okay, this is NYT and this is 0 1 0 1, and suppose here we have like this is a tree, like here we have a symbol A, okay, having the weight 1. Now this symbol A encountered second time, we just put the weight value 2 and the uh, we just send the only code 111. Okay, then we just send value 111. So for symbol which is already encountered, we just send the code for that particular symbol. Okay, now come to the NYT code. This NYT code can be find out by traversing the tree from root node to NYT code. Suppose we have a tree like this. Okay, this is NYT node. This is NYT. So we have to find the NYT code, we have to traverse from root node to NYT node. So this is 0 1 0 1 and 0 and so on. So the NYT code will be the if you traverse from the root node to NYT, the NYT code will be 0 then 1. So the NYT code will be 0 and 1. And the fixed code can be find out with the help of two conditions, and these two conditions we will discuss on the next slide. Now come to the parameters and conditions. Here we have used two parameters E and R. We will use two parameters E and R, and there is a equation, or we can say that there is a condition, that is m equals to 2 raised to the power E plus R, where R should be greater than or equal to 2 raised to the power E but less than or equal to 0. So uh, on solving this condition, we get 26 equals to 2 raised to the power 4 plus 10. Here m is the number of alphabets. Okay, number of alphabets. So we have A, B, C up to Z. So there are total 26 alphabets. Okay, number of alphabets. So we have 26 alphabets. So the value of m is 26, and the 2 raised to the power E plus R. If we put the value of E or R as 4 and 10, this equation will be satisfied. Okay, so the value of E always be 4 and the value of R will be 10. So value of E equals to 4, value of R equals to 10. We will consider for any length of message, or you can say that we consider this value E, R and R as 4 and 10 in any question, in any given question or any length of message. We always use this value E equals to 4 and R equals to 10. So for any given question, we will use the same value E equals to 4 and R equals to 10. Okay. Now come to the condition part. There are two conditions. On these conditions, whichever will be satisfied, on the basis of these conditions we find out the fixed code. Okay, the conditions are, these are these conditions are for the fixed codes. Okay, now come to the conditions. The first condition says that if the value of k is greater than or equal to 1 but less than or equal to 2r, it means the value of k, I am talking about the first condition. If the value of k is equal or greater than the 1 but less than or equal to the 2r, means less than or equal to 20. If the value of k lies between 1 to 20, then we will follow the first condition. Okay, and the second condition is when the value of k is greater than value of k is greater than 2r, 2r means 20, then we will apply second condition. Now if the condition first is satisfied, then what we have to do, we have to just encode e plus 1 bit binary representation of k minus 1. Okay, here k stands for the position of the symbol. Suppose we have a symbol like d. So in alphabet A, B, C, D up to Z, the position of D is 4. So the value of K equals to 4. Okay. Now check the condition. When the value of K equals to 4, which condition will be satisfied? First condition or second condition? The first condition will be satisfied because the value of K equals to 4 and the value of 4 is lies between the first condition, that is 4 is greater than 1 but less than 20. So we will consider first condition. If the value of k is 21, 22 or up to 26, then we will consider the second condition. Okay, when the first condition is satisfied, we have to encode e plus 1 bit binary representation of k minus 1. Okay, now when the k equals to 1, 4, it means the first condition is satisfied. Now what we have to do, we have to k minus 1 means 4 minus 1 equals to 3. Now we have to encode this 3 in e plus 1 bit binary representation. E plus 1 bit means we know that the value of e always be 4, so 4 plus 1 is 5. So we have to represent this 3 in 5 bit representation. Okay, now we have to encode this 3 in 5 bit representation, 5 bit representation. Okay, now suppose uh, if we talk about the second condition, in which the value of k is like 21 or 22 or 23 up to 26, then the second condition says that we have to e bit binary representation of k minus r minus 1. In this case, the position of the symbol, that is k, then what we have to do, we have to k minus 1, k minus r minus 1 means if the value of k is 22, suppose let's say the value of k is 22, then 22 minus 10 minus 1, that is 11. Then this 11 we have to represent in e bit, means in 4 bit. Okay, now in next slide we will discuss an example, and I'm sure that you will easily understand about the encoding part of this adaptive Huffman code. Okay, now come to the encoding procedure. So suppose we have a message AARDVAR. Okay, now in this we have to encode the message by adaptive Huffman. Okay, now the string is AARDVAR. Let's say AARDVAR. Okay, so first of all we know that there is an NYT node which will be used to update our tree. So first is NYT node. This is NYT node. Okay, having the weight always 0. Okay, now the first symbol is a, and this a symbol is encountered first time. Okay, now for this a we have to find out the for a, I am talking about the first symbol a. Okay, for a we have to find out the NYT code as well as NYT code as well as fixed code. Okay, Now here, this is the first symbol encountered in a tree. So the NYT code will be blank plus fixed code. Okay. For the fixed code, we know that the for this symbol A, the value of k equals to 1, because in alphabet dictionary A B C D F to Z, the position of A equals to 1. So as the value of k is 1, it means the first condition is satisfied. First condition is satisfied. It means we have to encode k minus 1, that is 1 minus 1 equals 0. We have to represent the 0 in e plus 1 bit binary representation. E plus 1 means e, we know that the e equals to 4 and r equals to 10. So we have to convert the 0 in e plus 1 means 5 bit representation. So we can write this 0 as 5 bit representation. So 5 times 0. So here the NYT code is blank, nothing, and the fixed code is 5 times 0. Okay. So for this A, first A, we have a code 5 times 0. Okay. Now what we have to do, we have to just update our tree. So this NYT, we know that whenever a symbol is encountered, the NYT plays its role. So this NYT creates a node and join on its left hand side is NYT. Okay. Now this symbol A will join on A, and this symbol is encountered first time, so the weight is 1 and NYT has weight over 0. So 0 plus 1 is 1. Okay. So at this moment we have updated our tree as per the first symbol A. Okay. Now come to the second part. Come to the second symbol. The second symbol is already A, as already encountered previously. So the second symbol is A and is encountered second time. So what we have to do? We have to just update our tree and send a code. Okay. So at this moment we have a weight on the edges 0 and 1. So in this case the code is uh, we have to just send the code, and the code is from root to the particular that symbol. So the code will be 1. So for this particular A, we have code only 1. Okay. Now we have to update the tree as per this symbol A. So we have a new updated tree, that is NYT. Okay. Now here is 0. Sorry, here is 0, and here the symbol is A having weight 2. Okay, now 0 plus 2 is 2. Okay, now come to the next part. Okay, now we have a symbol, sorry, we have a string AAR AAR DB AAR DB ARK. Okay, this symbol have the code 5 times 0, and this A having the code 0. Now we have to work on this R. Okay, at this particular moment we have the tree like this. This is NYT node, and this is node A having the weight 2, and NYT node having 0, and the root node having the weight 2. Okay, now we have to work on this symbol R. So this symbol R is encountered first time. So what we have to do for particular R, the value of k, for particular R we have to find out the code, and that code is the combination of NYT code plus fixed code. Okay, fixed code. Now what is the NYT code? NYT code is the value, or NYT code is a code by traversing from root to NYT node. So from, if we traverse from root to NYT node, we just get only 0. So the NYT code is 0. Now come to the fixed part. For fixed part, the value of k for this symbol, the value of k is, 18. Okay, now k equals to 18. When the k value of k is 18, it means the first condition will satisfy, because the first condition says that if the value of k lies between 0 to 20. Okay, so in, as per this first condition, we have to encode k minus 1 means 17. Okay, bit 17 represent in E plus 1 bit means E equals to 4 and R is 10, R equals to 10. So E plus 1 bit means 5 bit. So we can represent 17 and 5 bit, we get 10001. Okay. So the fixed code is, final fixed code is 10001. So overall code for R will be 0, NYT code is 0. Okay. And the fixed code will be 10001, 10001. Okay. Now we have to update this tree. If we update this string again, this root, this NYT node will, this is A having the weight 2. Now this NYT node create a intermediate node and join on the left hand side NYT, and at this right hand side we place the symbol R having the weight 1, NYT node has weight 0. So 0 plus 1 is 1, 1 plus 2 is 3. Okay. Now here we can easily check the weight of each node. So the weight of each node here is the weight of left node is 1 and the right node is 2, and we know that the weight of the left child should be equal or less than the right child. So here the weight of at this particular moment is 1 and at this moment the weight is 2, so the condition is already satisfied. Now this is our updated tree up to R. Now come to the next letter. So the next letter which is being encountered is T. Now for D, letter D. So letter again for letter D we have to find the NYT. We have to find the NYT code plus fixed code. Okay, plus fixed code. So NYT is NYT node is by traversing the root, by traversing the uh, from root to NYT node. Here we have 0 1 then 0 1. So here the NYT code will be, if you traverse from root to NYT node, 0 then again 0, so the NYT code will be 0 0. Now come to the fixed code. For fixed code the value of k equals to 4. It means the condition first is satisfied. It means we have to encode 3 in 5 bits. Okay, so we have to encode 3 in 5 bits. If we encode the 3 in 5 bits in binary representation, we will get the 00011. So the final code for D will be 00, this 00, and this one, this thing 00011. So finally the code for D will be 5 times 0, 1 2 3 4 5 times 0 double 1. Okay, now update this tree. So by updating this tree we get this is root node, then again root node here, symbol A having the weight 2, then again on the right hand side we have let symbol R with weight 1, then this NYT creates intermediate node and join on the left hand side having weight 0, and on the right hand side we just join the symbol D, okay, having the weight 1. Okay, this is NYT node. So again 0 plus 1 is 1, 1 plus 1 is 2, and 2 plus 2 is 4. Okay, now up to this level we as per the given tree, as per this updated tree, here the weight of symbol A is 2, and if we traverse this sequence, already A is encountered 2 times. Okay, R is 1, so R encountered only single time, then D is encountered 1 time, so here single D is presented in the sequence. Okay, now if we check the condition of left and right nodes, here the weight of the left child is less than or equal to the right, so the condition is satisfied here. Now again if we check the condition, here left is already less than or equal to the right, so here is also uh, condition is satisfied. Now come to the next symbol, and the next symbol is B. So at this moment we have to find out the code for symbol B, which is encountered first time in the tree. Okay, now I am going to draw this tree again in my next slide. So as per the previous slide, we have a tree like there is a root, then we have left, then we have on the right hand side we have symbol A with uh, bit 2, then we have left part, then part 1, then we have outside inverting 0, and is letter symbol D with 0 plus 1, 1 plus 1. This is 2 and 2 plus 2 is 4. Okay, now 0, 1, 0, 1, 0. Okay, now as per the given string, we have A, A, R, U, B, A, R, Q. Okay. At this moment, we have already encoded for this A, this A, this R, and this T. Now we have to work for this one. As this symbol V is encountered first time, so we have to find the code, and the code will be NYT code for V. I am talking about the symbol V. So the code will be combination of NYT code as well as fixed code. Okay. So for letter B, we have to find the NYT code, and the NYT code is by traversing the from root to NYT code, we get the 0, then again 0 and 0. So we have NYT code 2.0. Okay, and now come to the fixed code. Okay, so for the simple V, the value of k is 22. Okay, now at this moment, if we check the condition, the second condition is satisfied because the value of k is greater than the uh, 2r. Okay, as we know that the value of p equals to 4 and r equals to 10. So the second condition is satisfied. So on the basis of second condition, what we have to do, we have to encode k minus r minus 1 in e bit. Okay, so k minus r minus 1 means 22 minus 10 minus 1, that is 11. So we have to represent 11 in e bit. E means 4 bit. Okay, so we can easily represent 11 as in 4 bit. So we have 1011. Okay, so here NYT code is 000 and the fixed code is 1011. So what we have to do, so for this symbol B, we have the code is 0001011. Okay, now what we have to do, we have to update our tree. So by putting the symbol B on T, and with the help of NYT, we can easily put this symbol in a tree. So again, this is root node, this is symbol, sorry, this is this can be represented by this square. This is A, and the weight is 2, and again here is 2. This is symbol R. Okay, now here is symbol D, where the weight 1. Now here is weighting, and this weighting weight intermediate and join on the left hand side and by T, and on the right hand side we just add the symbol V having the weight 1 because this symbol 1, sorry, this symbol V is encountered first time in a tree. So here MIT value is 0, MIT weight is 0, so 0 plus 1 is 1, 1 plus 1 is 2. Okay, here the weight of R is 1, so 2 plus 1 is 3, and 3 plus 2 is 5. Okay, now we have to again check all the conditions, whether the left child is less than equal to the right child or no. Here the condition is satisfied. Okay, now if we take a look on this level, here the left node has the weight greater than the right, so the condition is false. So what we have to do, we have to just shuffle the branch of this tree at this particular moment. Okay, so by shuffling the branch, we have the new tree like this. So After shuffling, we have updated till like this. So this A will be drawn on left hand side, and this again. Now the letter R will be drawn on left hand side. This is a B. So this is one, and here the right is symbol D. Okay, now here is converting to 0. This is the letter symbol. So 0 plus 1 is 1, and the value of D is 1. Okay, so 1 plus 1 is 2. Now here is a symbol A having the weight 2. Okay, now here is the symbol R with 1. So 1 plus 2 is 2, and 2 plus 3 is 5. Now again check all the conditions. The left hand side the weight is 2, and the right hand side the weight is 3. So again the condition is satisfied. By traversing from leaf node to the root and check all the conditions whether the left child is less than or equal to right or not. So at this moment the tree is updated and fulfill all the conditions. Okay. Now what we have to do? Now we have to encode for this symbol A. As this symbol A is encountered third time, so what we have to do? We have to just send all the code itself. Okay, so here the 0 1 0 1 0 1 0 1. So for the symbol A we have to just send A only code, because A is not encountered first time, it encountered third time, so we just send the code. So this is the 0 will be the code for this A. Okay, so for this symbol A we just send the 0. Okay, and what we have to do, we have to just update this U by 1. Okay, so the weight will be 3. Okay, now come to this symbol R. This symbol R. So this symbol, again this symbol R is not encountered first time, it encountered second time. So what we have to do, we have to just send a code, and the code whatever we have to send the code, we have to traverse from root to that particular node. So from by traversing from root to R, we get the code 10. So we just send the code 10. For this R, we send 10. Okay, and we just update the tree by 1. So the weight will be uh, 2 in place of 1. So the weight of symbol R will be 2. Okay. So again 2 plus 2 is 4. Here weight is 3. So the 3 plus 4 is 7. Okay. Now we have the symbol K. This is the last symbol K. So what we have to do? Uh, we will discuss it on the next slide. So we have A, A, R, D, V, A, R, K. All these symbols we have already find out the code, as well as we have update our Huffman tree as per the given specs. Now come to this symbol. As this symbol encountered first time, okay. So what we have to do? We have to just find the code, and the code will be the combination of NYT code as well as fixed code. Okay, fixed code. Now I'm just trying the previous tree. Okay, so now I'm uh, drawing the previous tree. So the previous tree was like this. This is the root node. Then we have a symbol A having the weight 3. Then we have a again 4. Then we have a symbol R with weight 2. Then we have symbol again 2. Then we have 1. Then here is converting with 0. Then we have symbol V. Okay, now here we have a symbol uh, symbol D with width. Okay, now we have to work on this symbol. We have to find out the code for this symbol K, and as well as we have to update this tree. Okay, and the weight of root is 7. Now what we have to do? We just putting the values 0 1 0 1 0 1 0 1. Okay, now what we have to do, we have to find out the NYT code first. So by traversing from root to NYT, just 0, then 1, then 0 0. So the NYT code will be 0 1 0 0. Okay, so the NYT code is 0 1 0 0. Now come to the fixed code. Okay, so here the symbol is k, and what will be the value of k? The value of k already 11, because in alphabet dictionary the position of k is 11, so the value of k is 11. Okay, now as far as the value of k is 11 is concerned, this satisfies the first equation. Okay, first equation will be satisfied, and as per the first equation, k minus 1 will be represented in e plus 1 bit. Okay, so we know that e equals to 2 and r equals to 10. These values are always be same for any question, any length of question. Okay, so k minus 1 means 10. We have to represent this 10 in 5 bits. Okay, we have to represent this 10 in 5 represents. So we can easily write 10 represent as 101010. So we can easily find the code for simple case. Here the fixed code is 01010. So the final code for k will be 0100, then 01010. Okay, this is the code for simple k. Okay, now what we have to do, we have to just update our tree. Okay, so this NYT will be used. This NYT will be used for updating our tree. So we have the initial string is A A R D B A R K, and we have already found the code word for symbol K, that is 1100 Now we have to update the tree as per this symbol K. Okay. Now we have to update the tree. Update the tree. So in previous slide we have the intermediate tree structure, like this is node and this is letter symbol A having the weight 3. Okay, now this is intermediate node, then we have symbol R having the weight 2, then this is another intermediate node, and again this is intermediate node, there is leaf node, that is D having the weight 1, then we have uh, symbol V with weight 1. Now here in previous slide, here is the node NYT, and this NYT nodes create an intermediate and will join on the left hand side. This is NYT having the weight 0, and here the symbol K will join on the right hand side with weight 1. Okay, so 0 plus 1 is 1 and 1 plus 1 is 2, and 2 plus 1 is 3. Okay, and 2 plus 3 is 5. Now check all the conditions. The first condition is whether the left child is whether the left child having weight is less than or equal to the right child or no. So here the 0 and here 1, so condition is satisfied. Now come to this part, the left child having weight 1 and here right child having the weight 1. So here again the condition is satisfied. Now at this moment the weight of the left child is greater than 1, so the condition is false. So what we have to do, we have to just shuffle these two branches. Okay, now we have to shuffle these two branches. So what we have to do, we have to just update this tree. Now there is weight here. Now we have again root node, and on the left hand side we have symbol A having the weight 3, then again intermediate node. On the left hand side we have symbol R with weight 2, then again here is intermediate node, and the left part, this left part, the symbol D will join on the this right hand side. There is a symbol D, and this symbol will join on the left hand side after shuffling. Okay, so there will be a symbol D and the weight 1, and this portion will join on the right hand side. Okay, so the intermediate node will be joined on right hand side. Then we have intermediate node, again we have symbol B having weight 1, then again NYT node on the left hand side, then we have last symbol K with weight 1. So 0 plus 1 is 1, 1 plus 1 is 2, and 2 plus 1 is 3. Now check here, the left hand side having the weight 2 and the right hand side weight 3. Okay, now here the condition is satisfied, that is the left child the weight should be less than or equal to right hand side. Okay, so there the condition is satisfied. Now 2 plus 3 is 3 again. 2 plus 3 is 5. Okay, 2 plus 3 is 5, so 3 plus 5 is 8. So here the root node having the weight 8. Okay, now here at this moment the condition is satisfied. Okay, now at this point of time we have already find all the code words for the given symbols a a r d b a r a. Okay, so at this moment we have completed our example, and the example is to encode the sequence given sequence as per the adaptive Huffman coding. Okay, so finally we collect all the code words of individual symbols. So finally we have a code just like this. This is our final code word. Okay, this is our final code word. Okay, and in between we have already update our tree also. Okay, so I hope you all understand the adaptive Huffman coding with encoding procedure as well. Thank you very much.